So it's a real pleasure to be kind of opening this week. It sounds incredible, the number of things going on. So many thanks to FAO and others for the invite to deliver this. I'm going to keep it very high level, right? This is a keynote, to start off the week. And so I wanted to focus really on kind of the opportunities that we have in the digital space for innovation in agriculture, and then I'll get to like kind of where the data issue comes into that. But really, first of all, just to get a little bit excited, but also a kind of cautionary tale about what I call the other half, right? So I'll focus this talk on the digital agriculture for the other half, right? So it's this inclusion side of things. We get so excited about the opportunities, but we've got to be very mindful that those opportunities, we need to make sure that they're arriving to everyone in the world and not just a chosen few, right? So just to start off, just to explain a little bit where I'm coming from. I work in the CGIAR and work with the platform for big data in agriculture, which is the platform across CGIAR where we're working on everything digital and data. Really, we have a pretty bold objective here, and it's really to embrace big data approaches to solve development problems faster, better, and at greater scale than before, right? So we see a lot of opportunity in this space to do things different, to disrupt a little bit the way we go about doing research, use digital approaches, and in so doing, be much more efficient at developing global development. We're organized around three what we call modules. We're forced to call them modules, but these are the areas of work. And what we want to do is, first of all, we want to organize data, and so that is where this group is absolutely critical. This group of stakeholders. We want to work on convening partnerships. We believe that to have this kind of digital revolution, it needs new types of partnerships in the agricultural world. And then we want to inspire, so lead by example and show how, when you harness good data, when you harness new partnerships and great ideas, you can solve things in new and exciting ways. So that's where we're coming from. But let me now kind of frame a little bit the keynote, really. And we have this global food system which is full of paradoxes, and really this is the operating space we're working on. We need to feed 10 billion people by 2050, increase 60 to 70% of food produced. But right now, 30% of the food we currently produce goes to waste, right? So we need to up the game, but also reduce wastage. We have a paradox where 820 million people suffer from micro and macronutrient deficiencies, and 2.1 billion people are overweight and obese. And then we have the paradox of the agriculture is like the primary driver of deforestation and greenhouse gas emissions. It's a huge footprint in the global carbon budget. And agriculture also is the primary consumer of water. Without natural ecosystem services, agriculture is unable to survive and thrive. And then the fourth paradox we have is that there's a need to revitalize the rural sector. Yet those who would lead on that front, such as the youth, are migrating to urban areas due to the drudgery, the low returns, the high risk, low technification, and we think digitalization of agriculture. And so you have this global food system full of paradoxes and inequities. And so how are we? This is where we come from. How do we transform agriculture when there are over 570 million farms in the world to reach? It's very, very, very difficult to and this is why agriculture has been such a difficult sector to work on. It's highly fragmented. We need 570 million individual little businesses essentially to change behavior. And
Andy,
yes.
Andy, sorry, this is Maida. Your slides aren't advancing, and I know they're beautiful slides, so you might want to figure that out.
So you're seeing this screen, okay.
So we're stuck on feeding the future bite by bite, the title slides.
Oh, okay, wait a minute.
I don't know why.
I'm going through some beautiful slides here. Let me.
I know.
I'll tell you what I'll do is I'll just increase the size of this. I'm guessing that's the one you can see, right?
Yes.
In the future, yes.
Okay, so I have it on other screens. All right, I'll just go through.
Ah, now it works. Great, thanks.
Okay, okay, so yes, so that was the paradoxes. So yes, so these are, so this is the reality. We have 72% of those 570 million farms are smaller than 1 hectare. Let me just move the presentation so I can see it. Those farms that are under 200 hectares are producing 30 to 34% of the food supply. And so, you know, this is, there's a huge number of farms, a huge number of them are very small, and they're actually a large footprint in our food system. And so that is really important when we think about anything related to revolutionizing using digital agriculture approaches. Now, this is, I mean, this is now a little bit old, but this was a McKinsey report from 3 years ago. But it did a kind of an analysis of digitalization in the US, and agriculture came out number 23 of 23 sectors analyzed, right? So we are lagging behind on this digital side of things in the agricultural sector. We see that as an opportunity. It's an untapped potential, essentially, to look at new opportunities for this. But when you search for what is digital agriculture, you often get images like this. You get lots of photos of tractors and smart sensors and precision agriculture, which is really exciting and inspiring, but it's not applicable to many parts of the world. And so really what we're trying to look at, well, ask the question, well, what does this farm, you know, what's the equivalent of this kind of farm, which is, you can see big houses and big infrastructure and tractors and so on. What is the equivalent of that in a smallholder system, right? And so it's that translation that I think is absolutely critical if we are going to spur on a digital agriculture revolution that is inclusive, right? And so it changes the scale and the types of innovations that we should be targeting. And I'm going to show some of the exciting things that we've identified as opportunities for this in a smallholder system in a bit.
Andy, sorry, this is just to step in. I think you're having some slide issues again.
Oh, okay. What can you see now?
We can see the world map. How do we transform agriculture? So maybe try switching to present.
Yeah, that was what I was doing before, and on Zoom it's a bit clunky.
I know I had the same problem last week.
All right, let me turn it on. All right, we'll just have to problem solve it now. Okay, can you see that?
I see farms and texting cows.
Yeah, that's it. Okay, all right. So this is the utopia, the digital utopia in the United States. This is what we see for a smallholder system in Africa. Is the kind of equivalent of this. That over there. Okay. So so really what I'm kind of talking about is this inclusion agenda. How do we spur this digital agriculture revolution that is more inclusive? And it presents all sorts of new challenges and new ways of thinking. I mean, some of the challenges that we've got to think about is women are 14% less likely to own a mobile phone. Mobile phone has become the primary instrument for a lot of information services and digital solutions at the moment in Africa, for example. But women are less likely to own one. There's poorer network coverage for small farm sizes. We've been working with the University of British Columbia, and if you look at the statistics, a small farm is less likely to have network coverage than a large holding farm. And this is a global analysis, but especially so in Africa. You move away from cities and you move into kind of some of the more rural areas where farm sizes are very small, and you start to lose network coverage. And then you just think about the access to data, right? So 1 gigabyte of data service costs 75% of the average income for the poor. And so, you know, it's still an unattainable kind of service for many people in the world. And so we need to see data services themselves as a global public good, something that is an enabler, a necessary enabler to spur on development. So there's a big, strong inclusion agenda. Now, having said that, you know, there is still huge opportunities with mobile phones. So we need to push on the infrastructure and the access. We also need to push on getting using phones for the digital revolution. And so you have 6 billion people with mobile phones, and more than people having access to a toilet, which is quite a phenomenal statistic. So we see that as a game changer for both data collection and information dissemination and two-way communication. And I always just like to show this. I got this from a presentation by Robin Lugi in IBM, but it's just this image just shows the pace of change. This is the Pope doing a mass in 2005, and then the Pope doing a mass in 2013. And the change in 8 years in terms of mobile phone usage and habits has just been phenomenal, right? And I mean, from 2013 to 2020, it's the whole day, you know, everyone there is then doing Facebook Live, right? So it's really changing rapidly. So the thing with a mobile phone is that it offers so many opportunities, you know. So first of all, you can have a mobile phone, but then you can start using it to share information. And so we all know Facebook. These are a photo, for example, of a cow. We have some people talking about this is in the African dairy social network that they have in East Africa. And so they have farmers talking about some of the problems that they have. And this is happening. There's now over 200,000 subscribers to this group who are sharing information and sharing knowledge, sharing problems. And all of this is generating so many different things. We can identify that some people are buying or selling, other people have animal health issues. You can see some animal husbandry things. You can get location information from this. And so there's a huge wealth of information being generated. And so from a research data side of things, we need to be much better at plugging into this kind of data that is not as clean and a little bit dirty, but is incredibly valuable in terms of getting real-time information. Mobile phone is not just for sharing information on Facebook, it's also a sensor, right? And so something that we've been working with, one of our Inspire projects that we have is with Penn State University and indeed FAO, and it's Nuru, an AI extension agent. And so it uses a phone, a camera. If you have a smartphone with a camera, it's a simple app that basically you can work offline, where you just take a photo, hold the camera over a cassava leaf in this case, and it is doing sensorial analysis there of textures, colors of that leaf, and it gives you a probability of the cassava, in this case, having a mosaic virus disease. And so it's putting in the hands of the farmer diagnostic tools to be able to see what is happening in their field. And when connected to the internet, it is fantastic as well in terms of two-way communication. We can be getting reports of where cassava mosaic disease is being reported, and we can be returning to the farmer strategies in terms of management. And so this is another amazing thing you can do just with a smartphone with a camera. You can, and all of these little little ideas, innovations that I'm showing, at the bottom there's a link that you can click. But if you go to bigdata.cgir.org, you can explore a lot of these things I'm showing. Second one, another thing that we've been working on is in terms of getting better data, is also in revealing informal food systems. And so we have a huge kind of, when you look at the global food system, a large part of it, especially in developing countries, is informal. And so we have so little information on what food, where food's coming from, where it's going, who's buying it, what its quality is, etc. And so this is a big area we've been pushing on revealing these informal food systems. And so one of the ideas we had was in Vietnam. This is a team from CIAT that put together a Wi-Fi network in a market, and so in Hanoi. And so with this Wi-Fi, passers-by, people visiting the market, sellers can connect to the Wi-Fi network, and in connecting, we send out short little surveys. And so this has been fantastic resource. We've been monitoring 5 markets in Hanoi. And even during this COVID crisis, we've been able to watch and see how behavior is changing in terms of everything from the sellers through to the consumers and what people are buying. And so this is an ideal way of really revealing these informal food systems in real time at the market, at the point where a lot of interactions happen between agriculture and the food system. And so there's more information, beautiful videos and things also on the website on this one. Another innovation is, beyond the mobile phone and beyond Wi-Fi, is very small scale sensors and Internet of Things connectivity that allows you to track, again, informal, in this case, fisheries, small scale fisheries. So these are very small boats, tiny boats going out. This is in Timor, Timor-Este, and what it's showing is kind of where are these small scale fishing boats going. And so you can start to create heat maps in terms of fishing, manage small scale fisheries much more effectively through this kind of information flow. So this is some work that the World Fish has been doing, and again, on the website, there's some beautiful images and animations of where all of these boats are going. It's really kind of hypnotizing to watch. And sensors also have gone into the genetic world, and so this is an innovation that is using the sensor that was used in the Ebola crisis, essentially for real-time rapid sequencing of Ebola, now applied on wheat, and it's now being applied on a number of crops. But 3 years ago, we were kind of the pioneers in the agriculture sector getting this going, and essentially it's a mobile genomic lab in a four-wheel drive car. It can work fully off-grid. The bioinformatics run offline, and what it's been allowing is looking at rust, wheat rust in Ethiopia in real time. So as the season progresses and you start detecting wheat rust, we can quickly get the sequence and understand really what are the best management mechanisms that we should be using for this particular type of wheat rust that's appearing from season to season. And so this is providing real-time information for extension and for the agricultural system in itself to respond to emerging pest and disease issues. And so that one's now been running for 3 years out in the field and providing now a kind of a more systemic platform in Ethiopia linked to the national systems for monitoring. And the other area where we see an amazing amount of innovation going on right now is in satellite imagery. And so this is an example from the Indo-Ganges, where we have satellite imagery doing, this is some work from Stanford, but now more recently there's been some amazing work from IGAD looking at across India at during COVID crisis about harvesting and planting and dates and kind of areas that are under different types of land use. But satellite images is revolutionizing as well our ability of surveillance of the agricultural systems across the world. And so this is, in this case, yield forecasting across the Indo-Ganges in northern India. And then the final thing that we see is kind of revolutionary in all of this. We've had mobile phones, we have sensors, we have satellite imagery, but the other is just analytical capacity to pull all this together and make sense of data. And data is, our concept of data is going beyond very, very clean, kind of controlled experiment from research, but much more capacity to bring on multiple data streams and make sense, even with noisy data coming from things like social networks, from things like the Wi-Fi network and so on. And so we could be using AI tools, machine learning, all sorts of blended statistics to make sense of huge data sets and capture these non-linear responses in the agricultural system. This is some work from, I believe, Colombia, where there's a number of, this is just commercial data reported by farmers of a whole range of different variables. And we're trying to understand with this analysis how individual factors, variables affect the system. And so out of this, you can pull very, very concrete extension information for farmers to suggest what to do. So one area where we see, a big opportunity where you put all of this together, and this is the kind of the $100 million question in agricultural and digital agriculture for me, is how do we get sustained, personalized information services to smallholder farmers and the food system? And so, it's not generic information, but this information needs to be absolutely personalized. That's the name of the game. So a farmer isn't receiving information that in northern India, the conditions are like this. It's no, in your farm, the conditions are like this. These are some of the things that you should be thinking about doing. And so that personalization is critical. And there was an analysis by the Gates Foundation on this a few years back that did a kind of ex-ante assessment. Well, if we use digital advisory services, if we fully empower extension systems to go digital, what would be the returns? What would happen? And so in this ex-ante assessment, we found that there was this analysis of 50% increase in adoption rates, 30 to 40% increase in yields, 20 to 25% increase in farmer income, 30 to 45 times return in farmer income per dollar. So like a 30 to 45 return on investment is pretty impressive. And 10 times cost savings for public systems, because you're moving into digital platforms. You have a lot less operational costs of having people out in the field constantly making those visits. You can reach more people at a lower price. And so huge opportunities with this, but I'm painting this amazing rosy picture. The second part of my presentation will go into, well, what are some of the barriers and some of the constraints that we're seeing? So the reality with this is that we have the evidence is selective. This was an ex-ante assessment, but we still have so little evidence really of the true efficacy of this, that the data is constrained, and that's very much within the domain of this group and what you'll be discussing this week. The investment is not meeting expectations, and so there's an element of skepticism entering now. And the stakeholders are incredibly fragmented. I mean, this is a problem across agriculture, but this is really holding back the realization of this kind of digital extension vision out there. So I'll talk just mainly in the next few slides about some of the things that we're doing to try and come over some of these constraints. One is this evidence clearinghouse, which we've developed. And so this is about building more evidence. So that first issue of evidence, we're looking through this evidence clearinghouse to pull together experiences that we've had across the globe on digital agriculture solutions and do a quite robust analysis of, well, what's the evidence in terms of its efficacy? And so this is kind of crowdsourcing that information, a website where you can submit your interventions, and there's a whole rubric and criteria for evaluating them to give investors, donors, development actors better evidence on what's working, why, where, and how. So that's one thing. The second, though, is the data issue. And so this is really getting to the home of this group of what we're talking about this week. And it really is, a lot of this digital agriculture revolution is going to be powered by lovely data, as I call it, lovely data. That was when I was doing my PhD. Every time we took a data point, it would be, oh, lovely data. And so we're all data geeks on this call. And so, this is, if there's one thing that we need to fix for all of this innovation really to flourish, it's getting the data organized. And so I'm borrowing a number of slides here from Meda, who will be presenting, I understand, tomorrow afternoon, Europe time. This is really about the big data agriculture highway, which looks a little bit like this. It's not quite up to the expectations that we have. And so there's potholes and there's dangers of dirty data. throughout the agricultural sector. And so this is the problem that we need to work to solve. And I must admit, I have, the COVID crisis has brought about a pretty serious bout of big data envy. It's not big data envy, it's big data envy. And you look at health, the health sector, and I'm sure everybody on this call has one way or another interacted with this data or this visualization from Johns Hopkins. But you have just, I mean, the world is moaning about the data, but in the health sector right now, it is incredible the amount of publicly available, visible, real-time, dynamic information on COVID across the world. And it's all synthesized into one beautiful little dashboard that's housed by Johns Hopkins. And so I have huge envy for this. It's incredible. But you ask in the agriculture sector right now, well, how many hectares of wheat have we planted in the last week? Or how much wheat was harvested in the last 2 weeks that is going to feed 6 billion people? We have no idea. And that is a fundamental problem that we have in the agricultural sector that needs solving. We need to fix this, right? And so this is a big push that we have in the platform for big data in agriculture. So these are some of the questions that we keep getting, and I'll go through these quite quick because I think Meta will go into a lot more detail on some of these slides. But you know, we're getting where can I find data on nutritional status of women? What does variation in crop response to fertilizer look like for sub-Saharan Africa? These are some of the kind of both research questions, but also development questions that are being asked of us, kind of the data scientists working in agriculture. I've been told I need to make my data fair. How do I do this? I want to access land use change as a climate adaptation strategy at national and subnational level in Africa. My organization has no repository. So many questions about data, both in terms of use, but also just how to curate and look after your data that is being generated in every organization, in every institution, by every scientist on an hourly basis, practically. And so we're driven by this vision of data being fair, findable, accessible, interoperable, and reusable. And so that we're looking to create the tools and empower people in the agricultural sector to be able to do this, essentially to make their data fair. And so we've got a few things that we feel like we need to get right. One is the systems. And so for this, we've been working very hard on Guardian. And so again, I'm borrowing a whole load of stuff here from Meta Devari, and you'll get a lot more detail on this tomorrow. But Guardian is the one-stop shop where we're trying to make one single entry point into all of the first data sets of the CGIAR, but we're looking to go way beyond that and connect into other agricultural repositories and data sets out there, so that we're, the more data, the better synthesis, the more power that we have in terms of the analytics and the use of it, right? So you can go into Guardian, guardian.bigdata.cgiar.org. You can search for example, nutrition women, and you've, out of a total of 19,000, this is an oldish slide, it's probably a lot more now, 19,000 data sets, 155,000 publications, then you can get a readout in terms of some of the resources that you might be able to tap into. And it's coming from different sites, all right? So Guardian is really just a portal into then connecting to all of the repositories that are out there that could be of interest. So this is, for example, data from DFID UKA. There's some data coming in from USA Development Lab, the data.gov.in, so data from the Indian government they're coming in. So you can get a readout of all of those data sources. So that's the one stop, the system that allows you to access this, to tap into this data. Now, the other thing we need to get right behind this, and I'm sure you all know this way better than me, but ontologies. This is the kind of the dirty laundry of data of the data world, where we need to make sure that our ontologies are clean for external consumption. And so ontologies are absolutely critical that we get them right, and that as a sector and as a group, as a community, we start moving towards better standards, more coherence to these standards, so that this data can become truly interoperable. And so just some of the work that we've been doing, the crop ontology curation tool, for example, we've been looking in, and we've kind of developed all of these standards and all of these ontologies. Elizabeth Arnault leading our community of practice working on ontologies. And this is absolutely critical work to enable the rest, and a huge amount of effort. We also need to get right the data inflows, right? So right now what tends to happen is the thought of sharing your data is an afterthought. It's kind of, okay, I've done all this, I've collected all this data, or I've done all this analysis, maybe I've done my publication, but oh no, I need to now like share it. Oh my God, how do I do that? And it's like a burden at the end, and it's kind of the last thing you do, and it's always the thing you don't ever have the time to actually do. And so getting the data inflows right, so that from the point where you're taking the data, it's coming in standardized and in a coherent database is absolutely critical. Something that we've been pushing for across the CGIAR operations here is with AgroFIMS. So this agronomy field information management system, so that, from the point the data is taken in the field, using ICT tools, field workers are collecting standardized, ontologized agronomic data. And so then that data is going into the system from the start in a much more organized manner, facilitating in the end then making it fair and available. So AgroFIMS has been kind of our effort on that, but we all need to work on these, what I call these data inflows. And then the final thing we need to get right is the aggregation and synthesis, right? So it's great having loads of data out there, but if we just go back to that example of Johns Hopkins, I think what they've done with that dashboard is an amazing visualization, an amazing aggregation of multiple data sets and synthesis, so that a user can immediately connect with the data, understand it, interact with it, and then subsequently they could download it and use it in their research. So this is an example that Robert Hymans has been working on from UC Davis, using data from Guardian, plugging into all of these data sources that are out there on in this case, crop response to nitrogen fertilizer across Southern Africa. And I'm beginning to create these pictures of kind of response, yield response to nitrogen. And so this is using 200 plus individual data sets. They're all data sets that were collected in different ways, in different, by different groups, with different methodologies. And, but because they're ontologized, because they're available in Guardian and discoverable, findable, accessible, interoperable, and so therefore also reusable, we can create these kinds of amazing syntheses. And so this is really where we need to get to. The users can say, what is the crop response to nitrogen fertilizer? And these kinds of visualizations can come up, and you can zoom in and look, I'm just interested in Malawi. Let's visualize the response in Malawi. So this is really where we need to get to. Okay, so I'm coming to an end, 9:42, good timing. So this is, a lot of what I've been showing has been part of our work, first on the organize, the data side of things, on convene through the partnerships, but also our inspire process. So in some of those innovations that were shown at the start are these innovations that have come out from our Inspire Challenge. And I invite you all to take a look at bigdata.cgir.org/inspire. It's open right now for grants and challenge funding, essentially, to come up with fascinating, amazing, exciting ideas around these 4 topics that solve global development problems, and pilot them, try them out. And so there's funding available for this, and the challenge is open right now for applications. I think that's all from me. So I'll stop there, and I guess we're going to go into.
Thank you very much, Andy. And yes, as he said, we'll leave a few minutes here at the end if anyone has any questions. You should have the ability to unmute yourself if you'd like, or if you feel more comfortable, if you want to use the chat to ask a question. We'll just spend the next 5 or 10 minutes on questions. So feel free to ask away.
Hi, this is Eric Antesana. Can you hear me?
Yes, we can.
Hi, this is Eric Antesana from Bayer Crop Science. First of all, thank you very much for the keynote. Very nice presentation. I was wondering about the role or the involvement of industry or companies within the approach you have in the exercises that you have been doing in your institution. If you could comment on some examples, are you working together with industry? Do you have any, let's say, common approaches, common projects on which you are working on, or a couple of examples?
Yeah, sure. I mean, we're looking. I mean, we see exactly the partnerships that are needed for this is absolutely essential. That it's not just public sector organizations, governments, but also private sector to be involved. I mean, you know, so much of the innovation that's going on right now in digital agriculture is in the private sector sphere. And so, you know, for companies like Bayer that are looking at, you know, doing a lot of work on the kind of upstream research, product development side of things, you know, I think, you know, there's a lot of opportunity there, and we would like to connect with as many companies as possible to make kind of pre-competitive data available, and work on the ontologies and the data standards to facilitate that to happen. You know, I think that's critical. But then on the development side of things, you know, on the downstream, on many of these innovations that I was showing, there are private sector partners that are involved. So, for example, the World Fish example with these small sensors, it's working with a company, a startup in Silicon Valley that are developing these small-scale sensors. So yes, I mean, I absolutely think the digital revolution is right now, especially it's private sector driven at the moment, and we're very interested in connecting and using and harnessing those kinds of partnerships to help ensure that the innovations reach not just the rich that have the business model is much easier for digital agriculture for rich farmers. How can we ensure that smallholder farmers also get beneficial access to these kinds of technologies and resources? And I'd just like to say, I have colleagues, Jawu is on the call, Meda is on the call, also from the platform, and maybe you're also welcome to jump in and answer any of the questions that come up. I see a lot of familiar faces on the list. Elizabeth, Rodrigo. So Andres has mentioned the evidence clearinghouse. Hi, Andres. Yes, we see this evidence clearinghouse as really critical. It's one of these things where we need to get enough evidence in there for it to be useful. It's kind of it's about getting the content and creating a little bit of a community around it where people are crowdsourcing and people are inputting their interventions. But then, you know, we see it as absolutely crucial then as a means of understanding, really learning what innovations are working best, where, why, how, and helping the kind of the donor community, but also helping kind of investors, the investment community, to kind of benchmark and to understand, you know, where are the best bets in terms of investment and effort. So yeah, there's a lot of, you know, and on the negative side, there's a lot of snake oil out there. You know, everyone is, if you're a farmer, You know, we've had this idea at Jawu and a few others of like kind of pretending to be a farmer in some site and registering with all of these information services that are available to you. So there's lots of companies now providing seasonal forecasts or digital extension recommendations and so on and so forth. And you know, our hypothesis is that there's quite a lot of snake oil and quite poor quality service products out there, and that's a danger for the digital agriculture kind of sector as a whole, because if people lose confidence in these kinds of things, then the good interventions and the good services will suffer also as a consequence. And so you know, I think that evidence clearinghouse is with a view to upping the quality of the innovations out there.
Andy, Andres here. Thank you for that. And you bring up that topic of reputation, not just of individuals that might be peddling snake oil or not, but really of the whole business of crop consulting in general. About 15 years ago, I was in a meeting of an organization of crop consultants in the United States. It's the National Alliance of Independent Crop Consultants. And even back then, they were really worried as a sort of existential threat to their profession, how as digital tools progress, that the easily verifiable fact that 3 different people would come up with 3 different recommendations, some of which were completely incompatible, would eventually have a bad effect on their profession. And that's only accelerated tenfold since then. So having things like this clearinghouse and strengthening efforts like the digital agronomy community of practice and deliverables coming from there about how to verify or document the sound agronomic or scientific principles behind a recommendation, I think is something that's going to be really helpful.
Yeah, I agree, exactly. So there's another question in there about one of the reasons for the success of the Johns Hopkins dashboard has been to leave its data open. In the case of agriculture, you have to be very careful when you open certain data. Could you go into these aspects in a little more detail? Yeah, I mean, but just like in health, you have privacy issues. Privacy issues are a big issue. But the same with COVID. I mean, that Johns Hopkins data isn't giving you any identifiable data. Personal identification, personally identifiable data it's absent in there. It's aggregating up, but it's still incredibly useful. And so I think there's ample approaches and systems and tools and ways of ensuring that data from agriculture is respecting people's privacy, but making available information, right? And so I think there are ways around a lot of that. But just again, I would say, just like in health, there's also an element of kind of competition and reputation that people are not necessarily, countries would maybe want to censor a little bit some of the data. That's been happening in COVID, but I think again, that the system can tolerate a little bit of that, but if we're still way behind, we need to get much better at making data fair, findable, accessible, interoperable, and reusable, and much quicker. So the best data out there is always like 4 or 5 years old, and that doesn't allow you to manage an incredibly dynamic, incredibly complex food system effectively.